Recording in progress.
So welcome everybody at the BEVSIM webinar. BEVSIM stands for Battery Electric Vehicle Sustainable Impact Assessment Model. My name is Esther Zondervan. I'm a principal consultant at TNO in the field of circular plastics, and I'm moderating of this webinar. As you already was informed, this webinar is recorded. So if you don't want this, then please leave this webinar. First, I would like to introduce you to Raquel Ledo. She is the coordinator of the ALMA project of which BEVSIM tool model is part of. And Raquel, she has a postmaster degree in management of automotive enterprises. She has more than 50 years experience in the automotive sector, and currently she's head of the materials innovation area at CTEC. Raquel, the floor is yours.
Thank you very much, Esther, for your kind introduction. I would like to share my screen. I'm not sure if you are able to see. It's right?
Yes.
Yes? Okay, perfect. So welcome to all. We have organized this event with the objective of presenting a tool named BEVSIM. It will be my colleague Rajis who talks about this assessment tool. But firstly, I would like to introduce briefly ALMA project. As you probably know, ALMA is a collaborative project funded by the European Commission. We are 9 partners from 4 different countries, including 5 industries, 2 of them SMEs, 3 research and technology organizations, and 1 international association. I'm trying to pass, that is. The main project goal is to improve the efficiency and driving range of electric vehicles. We are approaching the challenge of developing a novel electric vehicle structure for a passenger car with reduced weight and environmental impact, thanks to the adoption of an integrated circular approach and, of course, at affordable costs. For this purpose, the technical challenges addressed by ALMA are use of novel lightweight materials, advanced high-strength steel grades, high-performance composites, and hybrid materials. We are going to apply also eco-design principles. That means the structure will be designed to be reused and recycled. We are developing also structural joining technologies with reversible ability to enable efficient separation of dissimilar material joints at the end of life. We have to guarantee also the structural integrity and the reliability of the novel structure, and we will do that thanks to a multi-scale model-based characterization tool. We will work also on monitoring the integrated system to detect and diagnose the structural health of the parts. It's clear that issues concerning recycling and recovery solutions are needed to be developed. And finally, but not less important, obviously, is the development of a life cycle costing and assessment methodology. This is the focus today, and it will be Rajis who talks just now about this. And this is a very brief summary, I think, during the of ALMA project. I think during this presentation, you will see our web and our data to know more about our project. But today I pass the moment to Rajis. Only to end my introduction, I would like to say that, as I explained at the beginning, this is a collaborative project with 9 partners. But today I would I would like to thank especially our colleagues, our partners from TNO and ISWA, who are preparing this event and are organizing. So thank you very much to you. And it's all from my part. Thank you to all attendees, and I hope this will be really interesting for you. Thank you very much.
Thank you very much, Raquel, for your nice introduction. So the next speaker we'll go to is Rajesh Mehta, and he will tell us about the BEVSIM model. Rajesh is a technology and management professional with 16 years of diversified experience in the global petrochemical industry. He has expertise in the corporate sustainability, in business and financial modeling. Currently, he is a senior consultant at TNO, and he advises industry and policy makers on the decarbonization and circular economy strategies. If you have any questions during the presentation of Rajesh, then please ask them in the chat. And after his presentation, we will take care of your questions. So Rajesh, the floor is yours.
Thank you, Esther, for the nice introduction. And good morning, good afternoon, and good evening, everyone, wherever you are in different parts of the world. And thanks a lot for attending today's webinar. It's a launch event for our tool BEVSIM, Battery Electric Vehicle Sustainability Impact Model. And we are launching it on World Creativity and Innovation Day. First, I would like to introduce you the tool and its value proposition, why we need such kind of a tool for automotive vehicles. I'll explain you the capabilities of the tool as we go through this webinar, and also should demonstrate the alpha test results and the simulation workflow for the BEVSIM tool. Finally, I would like to conclude the presentation with my closing remarks, and we will look forward to your questions on the BEVSIM tool or ALMA project in general. BEVSIM is a web-based tool on TNO platform. One can access it through logging in through an internet browser. It has been built on an R-Shiny platform. The main aspect of the tool is it has best-in-class LCA models for material production, processing, use phase, end-of-life fate, and end-of-life recycling processes, specially designed for automotive industry. You could model a battery electric vehicle or an ignition vehicle and make a comparison for segment C and segment D passenger cars here. The tool is customizable. One can model a full car, a subsystem, or a part for LCA, LCC, lifecycle costing, or circularity analysis for automotive specific products. There is also a possibility to include customer or user specific data sets in the tool. Since the tool is hosted on a platform which is web-based, version control is possible, and it's easy to update lifecycle inventory data sets compared to Excel-based sustainability impact assessment tools. You could compare different design alternatives. The tool is designed for non-LCA experts, especially. It's easy to do an early sustainability evaluation and also do faster LCAs and do scenario evaluation, such as what if for 2030, 2050 scenarios. The value proposition of the tool is it offers early screening of design alternatives in the product development phase, which offers significant savings in time and effort for performing LCA studies, especially for automotive manufacturers and their suppliers. It enables consistency across LCA studies for automotive applications, which is a big pain point if you see in the market today. It's a sector application-specific tool which offers simpler design and simplifies the sustainability aspect for the automotive industry. It also offers lower cost of ownership compared to full suite LCA softwares, and where you tend to rely heavily on LCA experts or deep knowledge on a specific material or metals or plastics, which BEVSIM really tries to address here. BEVSIM is designed for specific user segments. In this case, automotive manufacturers, tier 1 suppliers, tier 2 suppliers, material manufacturers, service companies, and research universities are the intended user segments. In terms of professionals, automotive engineers, product developers, or product designers could really use this tool for the sustainability evaluations. And of course, sustainability and LC experts are the focus area to use this tool to simplify their efforts on doing sustainability evaluation for automotive applications. We are also looking into how do you embed sustainability for automotive in academia. And that's where the tool also becomes interesting for research institutes and universities. The tool capabilities are straightforward. It's a single integrated tool which offers LCA, lifecycle assessment, lifecycle costing, and circularity assessment in a single application. It allows to measure impacts associated with lightweighting options, design alternatives, choice of a material from a material designer's point of view, choice of a subsystem of a car, or designing a product or a solution for a specific use case in mind. We also take into consideration different recycling aspects depending on the material which has gone into a specific application. BEVSIM covers the entire life cycle phases of an automotive application, right from raw material to processing and part production, the assembly operations. These are specifically designed for automotive industry, and it's indeed a gap. If you see in the current situation of LCS studies for automotive, these operations are missed in traditional LCS studies. So we have tried to bridge that gap by bringing in assembly operation data sets in BEVSIM. The use phase specific to segment C and segment D cars is included in BEVSIM as well, together with end of life and avoided material production due to recycling aspects. Here is a sample alpha test result for BEVSIM tool. We did this, we selected a specific use case on a subsystem where a chassis of a battery electric vehicle was modeled in BEVSIM and also in a commercial software, SIMA Pro, and we validated the results for BEVSIM on this test use case to prove that the methodologies and the calculations in the tool really mimics the performance of a commercial LC software. And the BEVSIM was successfully able to do it. This is one example, but we also tested the tool on 2 additional examples internally to demonstrate the capabilities of the tool and to make sure that there is consistency available from BEVSIM in comparison to commercial softwares which are available in the market. Now I will switch some gears here and would like you to give a quick walkthrough on a simulation workflow which a user would encounter in BEVSIM tool. BEVSIM offers a 7-step simulation process in which the first step, a user has to select its own design, which we call as user design. It could be a new car, a subsystem, or a part. And once user has selected a user design in BEVSIM, we offer the user to make an edit to the user design by modifying materials, their processing stages, or a specific part. And once a user design has been finalized, the steps 3 offers the user to make a selection of a reference design. This is to make sure comparability of a result is available to the user. And once a reference design is selected, this could be a reference design from the BEVSIM database, which we have of certain design options, or it could be a user designed reference design as well. Once the step 1 to 3 are completed, the user has to go forward and select a use phase method, depending on the vehicle of choice, be it a battery electric vehicle or an ignition vehicle, and the specific geography where the product is going for the use phase. We have designed BEVSIM to take into consideration different geographical aspects for coming in from the grid mixes, especially for Europe and key other countries of interest here. Once the use phase method has been finalized, The step 5 is selection of end of life scenarios after the vehicle completes the use phase. In this case, we offer the user to select the current end of life situation for automotive industry in Europe, or they could also do a what if scenario for the future for 2030 and 2050 in these scenarios. Various recycling options are also offered as option depending on the uh, material recycling technology fitment here. The step 6 is comparing the user design with reference design, making sure that everything is in place before the user goes for the final step, which is evaluating the sustainability impacts for LCA, LCC, and circularity impact assessment. Here is a glimpse of the user interface. Once the user enters into BEVSIM, he or she encounters a detailed manual which gives the information on references, definitions, and explanation of various definitions we use in BEVSIM, so that a user is brought to speed in terms of LCA and sustainability terminologies to actually enhance their learning and user experience for BEVSIM. In step 1, as I mentioned earlier, the user design is available. In this way, a user could go into a specific tab, which we call as user design, and available design options are given to the user, which the user need to select, or they could alternatively add a new design based on their requirement. In step 2, the user design can be modified, as you see, and this modification depends on the properties which affect the LCA or the properties which affect the LCC. And of course, you need to save your changes in the edit design option. Otherwise, those changes will not be recorded in the system. And there are other options when you go into the user design. You need to select the right materials and corresponding material processes for the materials. We offer 3 sequential steps based on the domain expertise we gain in from working with ALMA partners to take a raw material and process into a finished made part. And this functionality can be expanded. And there are parameters which the user could change depending on the specific requirement in terms of process efficiencies attached to the respective processing steps for their part or a subsystem. In step 3, the user has to select a reference design. Different reference designs are available. They could select one or more reference design depending on the case they are evaluating. And the step 4 is selection of a use phase method. As I mentioned, different geographical options are available depending on the electricity grid mix of the vehicle you're using it. So we offer the entire Western European countries as an option, and also the European industry average electricity grid mix. We also give an option for the futuristic grid mix, where the full green electricity grid mix scenario is available, and also 2050 scenario based on the forecast based on by the external agencies such as IEA. And in the step 5, as I mentioned, the end of life scenarios, 4 different end of life scenarios, recycling technologies are available here for the user: mechanical recycling, incineration, pyrolysis, and sololysis. Depending on the material technology fitment, a user could select the future scenarios for the required part. The example you see is for sheet metal composites. And as I mentioned here, once all these inputs are recorded in BEVSIM, a user should make a comparison of the user design and with the reference design, just to make sure that the bill of materials are recorded correctly. And in this step 6, you could actually see these records. And in case any changes are required, the user really need to go back to the step 1 and 2 to make sure that those changes are recorded correctly. And once everything is in place, then you go to step 7, where you see results associated with the final analysis. And I'm sorry, the screen seems to be frozen here. things. In the step 7, you can do sustainability impact assessment for the entire system, for entire car or their subsystems, and deep analysis is also possible at a material and part level. And you could also do a full comparison using the recipe midpoint method, which is a standard LCA methodology for analysis. And as I explained, the simulation or the tool also offers comparison for material circularity. We use Ellen MacArthur's material circularity index, which is available in the tool, and the user could actually see the material circularity based on the material which have been selected in the user. And here is an example snapshot where different materials which go into the use case which we tested out, those material circularity indicators are well calculated, and the final circularity performance at the car level is also visible here. Now moving on to lifecycle costing, in BEVSIM we use two different perspectives. One is a consumer perspective for doing LCC. Another one is a producer's perspective. In consumer's perspective, we include all the cost and revenues for the consumer, which also includes the acquisition, use cost, and taxes. And from the producer's point of view, if a producer would like to see what is a production cost attached to producing a specific material, right from raw material production to part processing, those aspects are taken into consideration. The producer perspective is really interesting for people, for product designers who are trying to evaluate the cost reduction by making decision lightweighting choices or by switching from one material to another material. In lifecycle costing aspect, the user can go in and make an edit for the cost elements associated with different materials and parts. We give a default database for different materials and processing for the automotive application in general, and this comes in from data which has been captured from public domain. But if there are specific requirements of the user is given a flexibility to update the default cost data sets with their own specific cost data in the tool. And here is an example lifecycle costing results from the consumer perspective, where you see the net impact of a vehicle 1 versus vehicle 2 are shown, which includes the entire aspects associated with acquisition of the vehicle, the usage of the vehicle, the end of life, and avoided impacts coming in from recycling as well. And from a producer point of view, we do the entire assessment, right from the supplier point of view, manufacturing, distribution, use phase, end of life, and the revenue which the producer would generate from the part. And multiple comparisons are possible at a single point of time. You could have a single reference solution, or you could have more than one reference solution to compare with. And as an example, here is a list of the cost database which gets popped up by the tool, and this can be updated based on the requirement of the user. Now, finally, I would like to close the presentation by stating that BEVSIM is designed to assess the environmental, circularity, and economic impacts of passenger vehicles across the entire life cycle. One could model a single part or a material or a full car using BEVSIM. It's an automotive application-specific tool which offers simpler design and simplifies the sustainability concepts for product engineers and designers and for manufacturing companies. And this also offers significant savings in time and effort in performing LCS. And the tool has been designed for known experts for early screening of design alternatives in the R&D phase. And it offers consistency across the LCA method studies, because the complex methodologies related to recycling aspects, related to allocation approaches, those have been hard-coded by TNO after studying what is a best-in-class and agreed or consensus-based methodology for the sector here. It offers lower total cost of ownership compared to full suite LCA softwares, which is definitely a plus for small and medium enterprises. Now, naturally, a question will arise, can I have access to the BEVSIM tool? Yes, of course. And it depends on the requirements of on your requirements. And please feel to reach out. Please feel free to reach out to me to discuss your specific requirements. Certain aspects I will have to mention here, which are complex, such as studying the varying impact of recycled content, has not been included yet, and we would like to include in the next planned update, which will be in Q4 2022. And I would like to thank you for listening to this presentation, and we would like to open the floor for questions or comments from the audience.
Thank you, Rajesh, for your very nice presentation. I'm very impressed by the model that you made and that you presented here. The floor is open for questions. So if you have any questions, please ask them in the chat. So that will be the easiest way. Rajesh, I was wondering, hearing your presentation. So it is about the battery electric vehicles. What about the other passengers vehicles categories? Are they included in BEVSIM as well?
Yes, indeed. That's a good question. So we have a battery electric vehicle model. We also have a gasoline-based vehicle, the ignition vehicle modeled as well, plus a diesel vehicle. But this is only for segment C and D cars, because that was the scope for ALMA project. And now the natural question would be, can this be expanded to other passenger vehicles or commercial vehicles? Yes. And for that, we are investigating how best to actually include those methodologies into consideration.
And is that included in the ALMA project, or is that another project? Will that be another project?
That will be in another project, because ALMA scope was in passengers C and D segments, which are essentially small cars, hatchback designs.
Okay, yeah. And then the BEVSIM tool, can it be customized for another organization, so specific for one organization?
Yes. So BEVSIM can be customized for a specific organization because it offers that flexibility, being a web-based tool. So we host it on a platform called TNO Diamonds platform. A user login and password is given, which allows confidentiality for the organization and also allows access rights. And this can also be customized for the specific organization based on their need. For example, the processing efficiency parameters or a specific product grade composition can be customized and developed for the specific organization. That is possible and can be kept confidential as well. So nobody except the specific organization can gain access to it.
Okay, and can you say anything about the cost?
Okay, that's a good one, really. So BEVSIM has been developed as part of collaborative effort in Project ALMA. Together, the IP remains with TNO because it was sponsored by the European Innovation Program. And we are also seeking development funding to expand the tool beyond segment C and D cars. That's one. So that's where we are looking forward to partners to take care of their niche requirements. But if there are specific requirements for users who can use the current version of the BEVSIM, the cost, I can definitely comment here, will be significantly lower than the commercial softwares which are available in the public domain. I would not like to comment which kind of commercial softwares are available, but this essentially lowers your cost by more than 60–70% compared to traditional LCA softwares. And it also reduces your dependence on professional LCA experts for your day-to-day queries on during product development. So that's an indirect cost saving as well.
Okay, I think that is a real benefit for the organizations that would like to work with the BEVSIM tool. So I'm impressed with that one. Just one more question is, will there be more use cases tested on BEVSIM model?
Indeed, that's a good one as well as a comment. So as of now, we have tested 2 alpha test cases in the development phase. And of course, the beta test results, beta testing was also done by ALMA partners to make sure that BEVSIM really functions for their requirement, industry and beyond industry requirement. So those test cases have been taken care of. There is definitely a concrete test case, which is ALMA project itself. We are going to do where the entire ALMA chassis body in white will be modeled, and we are going to do this test case as well. On top of it, we are already looking with potential collaborations with Brightlines Material Center, who have a strong automotive portfolio to identify specific use cases for their requirement. And if there are few potential opportunities or ideas with the participants, feel free to reach out to us. We are always open to connect with you and explore those possibilities.
That's nice. And please, for the participants, ask your questions in the chat. I see also another question in the chat. So first of all, they say thank you for the presentation. So that is for you, Rajesh.
Thank you.
And then I would like to ask specifically about the pre-treatment of battery recycling. Could you expand on this? How detailed is this, and maybe what choices have been made?
That's indeed a very specific and important aspect. So during our journey as in the tool development phase, we identified battery in production, and the recycling is definitely a missing link in LCA modeling space. So we reached out to battery experts within TNO to give us this information and insights. And what we found out was those insights are available to a certain extent, but definitely there are gaps on recycling methodologies for battery vehicles. For now, we use a standard LCA dataset which has been given to us by those experts. But in the next update, we would like to actually build on top of build on this battery recycling aspects. But for the sheet metal composites, for thermoplastics, for plastic mixtures, different recycling technologies are taken into consideration now. And we have also covered traditional materials recycling such as steel and aluminum as per the European geographic situation. We are going to actually expand, as I mentioned, on the recycling options for the users in the next update, where the user will be given a functionality to test out the what if scenario on what if the recycled content of steel increases from current industry average to twice, or the recycled content of aluminum increases from the current industry average to 60% for the automotive sector. But for battery, definitely a challenge for us to build, and we are looking forward to further information, data gathering as well.
Okay, thank you for that. I saw a hand raised, so if you would like to ask your question in person, that is also possible. So then I can give you the floor. I see here also the comment in the chat. So the hand is not raised anymore. So I think your question is maybe already answered. So from Theodora, very impressive tool. So compliments for that. A question about the LCA inputs. Are those predefined depending on the component or the user, or the users enter the bills of materials?
Yeah, that's a good one as well. So the user has to enter the bill of materials depending on the part or a subsystem or the entire car itself. And I would also like to highlight here, the bill of material at a car level is extremely complex and quite difficult to find in open domain, because that's a confidential or very sensitive information which the automotive players like to protect. So if you have the respective bill of materials input for data for your own part or subsystem, the tool really asks for it. And then you will have to punch in that number in the tool. What is hard-coded in the tool is the lifecycle impact inventories associated with respective materials or processing stages. And this is best in class. And why do I say so is we did thorough investigation on what is existing lifecycle impact inventories for different materials in commercial softwares, and are there any gaps? Of course, there were gaps, and we have actually bridged those gaps, picking in data from the right sources, such as latest lifecycle inventory from World Steel Association, the lifecycle inventory coming in from Aluminium Association, plastics lifecycle inventory coming in from the Plastics Europe, for the European plastics production statistics for all the 28 different LCIs they provide. So that has been included here. And that's definitely a step change or an enhancement coming in from what exists in traditional tools or softwares. And we have also eliminated the complexity associated with the user choices, because even the LCI experts tend to get confused on which LCI they have to pick up for steel when they see 7 different LCIs in commercial softwares. So we have removed the rest 6, which are non-relevant for automotive, and we have selected the most important and relevant LCI for those materials and their associated processes as well. Does this answer your question?
I think sure you are very complete. So sure, I think the answer is the question is answered. If there are any more questions, so please ask them in the chat or raise your hand. If no questions are coming, then well, I would like to thank especially the speakers for giving this presentation and for presenting the this one. I see that there was an earlier question in the chat. Maybe I missed it. Okay, yeah, thank you for that. There was also a question from, do you have also considered the strength and the stiffness of the different materials if you change the material, e.g. from steel to plastics?
Indeed. So that's so this information has to come in from domain experts or product developers. So for ALMA project, we got these insights from Ford, our partners in ALMA project, and also CTEC, who are the designers for the new battery electric vehicle structure, which has to perform the same functionality compared to traditional design or the reference design. So stress test or tensile stress or test or specific material specifications are tested out. And unless we receive those proof points, we do not make a comparison. So, and these proof points have to be provided by respective domain experts. So if you're using BEVSIM for your requirement, and if you are the domain expert, it's handy because those proof points on the material functionality performance are available with you. But if you are a sustainability professional or a expert or a sustainability manager who do not have this information or from the domain experts, you will have to reach out to them before you make a comparison, because it doesn't make sense to do a hypothetical comparison without sufficient proof points. Then you would be doing a what if scenario, which is of course fine to identify the potential of your idea as well when you are early in the design stage of evaluation.
Okay, so I think that are the questions that were there from the chat. So once again, Rajesh, thank you very much for presenting the model. Thanks the participant for listening. And if there are any questions coming up later, then I think you are feel free to contact Rajesh. He can be contacted by mail via rajesh.mehta@tno.nl. So I wish you all a pleasant afternoon or day or evening, whatever time zone you are in, and thank you for attending.
Thank you, everyone.